My name is Mahbub Rana. I have PhD in Corrosion Engineering from University of Manchester Institute of Science and Technology back in 1975. Since that time, I've been working on corrosion. I spent 18 years in academic field, established two universities, and rest of my life, almost about 28 years, I have spent in oil and gas, corrosion control, right in the field, not in the office. So I know in and outs of what's happening in the field, right from the downhole to the midstream and to the downstream, the corrosion problems. This is my introduction is there. I have my contact number. I have my email contact. I have my YouTube contact. Let's go to the next slide. As the first slide shows that this presentation is mainly about the intrusive corrosion monitoring in oil and gas. But I will explain to you first what is corrosion monitoring and what is corrosion evaluation. Because not many of the young engineers understand the difference between the corrosion monitoring and corrosion evaluation. Corrosion monitoring is the practice of measuring the corrosive and erosive characteristics of the environment and the fluid. This one, the corrosion monitoring, it does not give you any information regarding the what may be happening on the surface of the pipe wall or surface of the equipment wall, because this measures only the corrosivity and the erosivity of the fluid or the environment. Corrosion evaluation is the practice of measuring the changes in the characteristics of materials, such as loss of wall thickness, loss of ductility, and loss of integrity. Integrity may be from the mechanical or from the corrosion viewpoint. Next slide talks about what is corrosion monitoring technology. Because there is a very much confusion regarding all these technical terms. So the corrosion monitoring technology is cost-effective methods for assessing the condition of plant and mechanism for maximizing plant life cycle and minimizing life cycle cost. In general, corrosion monitoring technology covers the corrosion monitoring strategy, selection of monitoring evaluation techniques, monitoring evaluation locations, corrosion hardware selection, data collection, and data and cost analysis. This slide shows the purpose of corrosion monitoring. Why do you monitor the corrosion? The purpose first is it gives us early warning. What may be happening to the condition of the system. Not exactly, but it relates to the actual corrosion behavior of the material respect to the environment in which they are in contact with. The correlation of changes in process parameters and their effect on system corrosion oxygen ingress means that all those parameters like oxygen or corrosive constituents, as they change, they can change the corrosion pattern of the corrosion monitoring evaluation hardware and the probes in there. It also used as a diagnostic tool, identifying corrosion mechanism, cause and the rate controlling parameters such as pressure, temperature, pH, flow rate, oxygen sensors, etc. Selection of materials, mainly the corrosion inhibitors, optimizing corrosion control and mitigation strategy as far as the corrosion inhibitors are concerned. Product contamination, right, can also change the corrosive characteristics of the fluids. The management of maintenance, reduce maintenance and inspection cost. It also comes from the purpose of the corrosion monitoring. Risk-based inspection planning, reliability enhancement, and life extension, safety enhancement, and reduce environmental impact. Because if you can reduce the corrosion accidents, right, you can also reduce these environmental impacts and you can also enhance the safety. Integrity verification of process pigging, pipelines, and fixed assets. Optimize the use of opportunity crude oils in the refinery because as you change the crude, the corrosive characteristic changes. And the corrosion monitoring has to do in that. As the corrosion characteristic changes, the corrosion rate on monitoring devices will change. Then the economic benefits, of course, right, you can maximize your plant life and reduce your cost of maintenance. Now regulate capex and opex because if you know exactly what could be the corrosive characteristics of fluid, then you can make the right material selection and you can also have a control on your capital cost and operation cost. Application of corrosion monitoring. Corrosion monitoring is typically used in the following situation where risks are high. High pressure, high temperature, flammable, explosive, toxic processes. Process upsets expect to enhance corrosivity. Changes in operating conditions expect to cause significant changes in corrosion rate. Corrosion inhibitors are in use. Corrosive constituents are concentrated due to repeated cycling. Process feedstock is changed. Plant output operating parameters are changed from design specifications. In evaluating corrosion behavior of various metals and alloys, potential shifts are used to protect systems or structures. Product contamination due to corrosion is a vital concern. So these are all the applications where the corrosion monitoring has been used successfully. Also, it's very useful in giving you the correct data. Terminology is common in corrosion monitoring. Direct monitoring measures parameters directly affected by the corrosion processes. Indirect monitoring measures parameters either affect or affected by the corrosiveness of the environment or the products of the corrosion processes. Then the intrusive technique, which I will be talking about, requires access through the pipe or vessel wall for corrosion monitoring. The non-intrusive techniques, maybe I will give the seminar or a webinar next time on the non-intrusive corrosion monitoring techniques. They require no access through the pipe vessel wall for corrosion monitoring. Then what is real-time monitoring? Real-time monitoring is a measure that detect changes in the parameters under investigation, essentially as they occur. Online monitoring installation equipment for continuous monitoring metal loss, corrosion rate, or other parameters in an operating system. Data are obtained without removing the monitoring device. This is for online monitoring. It's very, very crucial, but sometimes the people, they are confused, right? That if they can re-simulate the conditional laboratory, they consider that as online monitoring, which is not true. Offline monitoring method in which a sample is taken for subsequent analysis. The direct intrusive corrosion monitoring techniques or the physical techniques like metal loss coupons, lactic resistance probes, inductive resistance, sand probes, visual inspection. The electrochemical technique based on direct current and alternating current. Direct current techniques are linear polarization resistance, zero resistance ammeter between dissimilar metals or alloys, zero resistance meter between same metals and alloys, potentiodynamic polarization, galvanodynamic polarization, electrochemical noise. The corrosion monitoring techniques based on the AC current applications like electrochemical impedance spectroscopy and harmonic distortion analysis. This slide shows the direct non-intrusive corrosion evaluation techniques. They are put in there just to make sure the audience don't get confused between the intrusive and non-intrusive techniques. The metal loss or thickness loss is done by the ultrasonic and acoustic camera, magnetic flux leakage, electromagnetic eddy current application, electromagnetic remote field techniques, radiography, surface activation and gamma radiometry, electrical field mapping, electrical field signature methods. Then the techniques are used to detect the cracks and the propagation of the cracks. Acoustic emission, ultrasonic flaw detection, ultrasonic flaw sizing, laser arrays, V-line tethered MFL pipeline inspection, fiber optics, magnetic image, microwave indirect detects, microwave techniques for indirect detect moisture under insolation, and hydro detector for the corrosion under insolation. So these are the techniques which are applied from outside the equipment structure and the pipelines to evaluate the state of corrosion and the state of the equipment. Indirect online corrosion monitoring techniques. The techniques are corrosion products analysis, hydrogen monitoring, and electrochemical techniques like corrosion potential to measure the E-core, water chemistry parameters which are used as indirect online corrosion monitoring, like pH, conductivity, dissolved oxygen, redox potentials. This can be done online as well and can be done indirect and can be considered as intrusive or non-intrusive depending upon the mode of application and their use. Other techniques like flow detection, flow regime where the flow is turbulent or streamlined, flow velocity, the velocity is under the critical velocity range or is beyond the critical velocity range, process parameters like pressure, temperature, dew point. Deposit monitoring is like fouling, mainly in the heat exchangers. Then external monitoring is the thermography or infrared, used mainly for the detection of the wall thickness of the storage tanks at high temperature. And of course, other equipment. It's very expensive technique. Indirect offline corrosion monitoring, water chemistry parameters, which we have to monitor what may be happening to the corrosivity of the fluid. In water chemistry, called the alkalinity, pH values, metal ion count like iron, copper, nickel, zinc, manganese, depending upon the metallurgy of the equipment, concentration of dissolved solids, which can cause the actual erosion issues in there. The suspended particle size also gain erosion issue. Gas analysis for hydrogen, H2S, CO2, residual oxygen like halogen, halides, and redox potential. Microbiological analysis like sulfide ion or sulfate ions or other microbiological valuation like iron analysis or iron-based bacteria, SRBs, anaerobes, and aerobes. Water chemistry, residual inhibitors, filmic corrosion inhibitors, reactant corrosion inhibitors, right? So if you want to really optimize the use of these inhibitors, you need to know that how much would be the residual of the inhibitors at the end point of the equipment where the liquid go through the whole system, right? And where you can get a better and accurate data for the residual of the corrosion inhibitors. Chemical analysis of process samples like total acid number, sulfur contents, nitrogen contents, salt content in crude oil. As you know, oil and gas industry is very huge, complicated industry. All sort of products are there, all sort of corrosion issues are there. Corrosion monitoring hardware, which is mainly used in the oil and gas facilities, one is based on the low pressure. Low pressure generally comes as a 1-inch full port wall mounting. Pressure rating is normally less than 1,500 psi, but to be on the safe side, it's better to use the pressure rating in the system, which is about 1,000 psi. Then these are fixed retractable hardware, coupons are installed, probes are installed, and sampling injection points are there, which are also can be fitted through 1-inch full port wall mounting devices. Other corrosion mounting hardware is the high pressure, which is 2-inch access fitting, is normally called 2-inch HPAF. Its pressure rating is to 6,000, but no, they have a better actually devices which can go to higher rating than the 6,000 psi. They are retrievable, right? That you can retrieve these devices or the probes under pressure. You don't have to shut down the system. And you can install the coupon, probes, and sampling injection points through the 2-inch high pressure access fitting. At this stage, I must make it to the audience that pressure rating is something which is a technical term, where you can use the low pressure access fitting or where one can use the high pressure access fitting. In fact, this is just only one issue in there. Second issue is the convenience and the obstruction. Now, these low pressure access fittings are longer than the high pressure access fittings. So they can extend to the size of about half a meter to 1 meter. And now if you use the access fitting on a low pressure pipe in area where there is a frequent movement of the people and the animals and the pipeline is right above ground, or maybe the sampling point or installation point is above ground, where you install this low pressure access fitting because of the pressure rating requirement, then this pressure access fitting will definitely obstruct the free flow of the traffic over the pipeline, which is very normal in some of the places, right, where the animals as well as the people, they just cross over the lines. So there we have to make sure that nobody tumbles over, otherwise it becomes a legal issue. In those areas, I personally prefer to use high pressure access fitting, which are much safer, maybe a little bit more expensive than low pressure access fitting, but it's much safer, right, from a safety point of view, at least for the people who are just stepping over. The corrosion monitoring location is a very important issue in the corrosion in oil and gas industry, particularly for the corrosion monitoring issues, that where and how to install these corrosion monitoring hardware. First of all, we'll see that in the pipelines, the corrosion monitoring can happen around the circumference. So where should we place the corrosion monitoring probes? There are quite a few number of possibilities of doing in that. And you can see these are the given in there. This is with the coupon, right, which is almost near the one surface of the wall. This is a disc coupon, which go all the way down to the lower end of the pipeline. This is in fact also a coupon installation, which go to the down to the end of the other line. This is a flush disc. In certain places where you have to use or pick the lines, there all this technique, this and this cannot be used because it requires right, a free flow for the pick. In that cases, we prefer to use the flush disc coupons, which cannot obstruct the flow of the liquid. These coupons, if you see that, they do have some disadvantage in the sense that downstream of these coupons, right, particularly one which goes all the way from one wall to other end of the pipeline, it can create turbulence downstream, which can cause a little bit of erosion in there. So the selection of and mounting of the corrosion monitoring is very, very important. And it is not actually so suggested, right, in textbooks, but it comes from the experience of people and the people who are working in the industry, that where they should install and how should they install these corrosion monitoring devices. These are the actual at the bottom of the line with external right access. There's a single probe tap retrieving from underneath. There's a single probe tap retriever from the side. This is a double probe trap retriever from the sides. This is a double probe trap retrieve from sides, hot tappable. All these mounting devices, either they are installed at the construction stage and they are recommended at the feed and design stage. But if they are needed to be installed, right, while the system is on, then they are to be installed through hot tapping, because nobody would like to shut down the processes just to install the corrosion monitoring devices. And same is true, the hot tapping is very successful and technically very useful technique to install the corrosion monitoring devices without shutting down the system. Otherwise, the corrosion people have to wait till the system is shut down for annual shutdown or for accidental shutdowns. Then they can install the devices, right? Even then, they have to be very, very careful when they're installing the devices from safety point of view. Corrosion monitoring location for the vessels, these are given in there on the inlet pipe. You can install this chemical injection point, right? Then you can have the corrosion monitoring in the dead gas traps. Then you can have corrosion monitoring on the escape from the vessels. Then you can also have the corrosion monitoring device right in the gas exit or gas outlet. At the bottom of the line, usually in the vessels, if the water is going to separate, like the separators, the water is going to separate at the bottom of the line, then obviously one can install these corrosion monitoring devices in there for the for the flowing liquid as well as the dead legs. These give you very good information about the condition of the vessels. The dead legs are the ones which are most vulnerable to corrosion and accidents. They are just a small piece of pipe in there, but it has a very critical role to play in the safety of the vessel and its continuous operation. In the chokes, we can install the corrosion monitoring devices, right? The different type of chokes, and they are just installed the corrosion monitoring devices, right, at different places. It's a continuous operation. In the chokes, we can install the corrosion monitoring devices, right? The different type of chokes, and they are just installed the corrosion monitoring devices, right, at different places. The corrosion monitoring location for the main line, which are cross-country line, which are usually quite big lines, right? Generally about 20 inches diameter. Sorry. There, if the pipelines are always put underground. For underground pipelines, we need to have a underground pit, right, as you see in there. And then we have to install the boot in there. In the boot, we can install different type of corrosion monitoring devices. And this boot has to be, right, emptied from time to time. And at least when the people, they go for the corrosion monitoring, because mainly we install the ER probes in there. So we have to eject entire liquid from there, right, to make sure that the people who are working there, they are not subjected to any kind of hazard situation. And at the same time, people in there, they monitor the actual corrosion readings. And we always prefer to have 2 safety valves there, not one. In case the one is plugged, right, or the one is stuck. So we can easily, right, close the other valve. And when the people, they take the reading and they have to empty this one, the boot at the bottom, they have to close this valve to make sure that no gas or any crude oil, any other hazard liquid can escape from it. This is also the actual flow line installation of the corrosion monitoring device at different places. This is through the bypass. This is a main line. It all depends on what the people or the engineer decide to go for. Should they go for a bypass where they should install the equipment or the the corrosion monitoring hardware, or they should install the corrosion monitoring hardware right on the flow line. It all depends on the engineers or the designer at the stage they are designing the system. This is another issue of the corrosion monitoring location on the pipelines, right, which is better and more clear if it's given in there. The most critical part of the installation of the corrosion monitoring devices is on these pipelines, right, which are coming from top to bottom or bottom top. They are slanting in nature. So where to install the corrosion monitoring probes on these devices? So these devices are actually installed at these places where there's a full bore flow of the liquid. If the pipeline is flow is coming from top to bottom, the same as if the flow is going from bottom to top, even then this side of the wall is always covered with water. Side stream corrosion monitoring hardware. This is another way of installing our corrosion monitoring devices. Then to install it on the actual main equipment on the main line, we just can have a side stream by the different facilities install different type of probes and different type of corrosion monitoring hardwares, and it can go up to the pressure of low pressure, high pressure fittings are also available. So it will be between the upstream and downstream with flexible hoses. So this is another technique that we follow it in the industry. Instead of disrupting the main process, we just install the side stream facilities there, and in there we install the actual corrosion monitoring hardware. This is the shape of the 2-inch high pressure access fittings, the hollow and solid plug mounting assemblies. These are the 2-inch high pressure fittings, right? They are the welding, they're designed for different welding type and right, but they are mainly in the same pressure rating, regardless of what they look like and how they're designed at the bottom for the welding purpose. These are the actual hollow plug assembly mainly used for the installation of the coupons or the sand probes, and the solid plug assemblies, the hollow plugs are used for the ER probes and LPR probes, and for the sand probes. Solid plug assembly is used mainly for the coupon installation, and these are two different techniques. Here, the system can pass through the hole in there. Here, the hole is actually blocked, so the device has to be fixed over here, and then these devices are installed into one of these access fitting which are already welded to the pipeline, right, for monitoring the corrosion rate. The corrosion coupons principle and monitoring principle is this a physical technique. It's not something chemical, electrochemical, or any other technique. It's just a simple physical technique. It's a direct, intrusive, offline technique. Means you cannot measure, right, the corrosion losses or the actual condition of the probes online. So the probe has to be taken out. And how the probe can be taken out, we can use actually the retrievers and the retractor online to take the coupons out. But still, it has to go to the laboratory for the analysis. Then the metal lose weight when undergo corrosion, and start also these inhibitors, the coupons, they give the indication that how much could likely to be the corrosion rate at the surface of the structure or the pipe metal, but not exactly what may be happening at the pipe surface or the structure surface. This is a relative technique which can give you that how the corrosive condition of the fluid or the environment or the electrolyte that may be behaving and changing with the changing in the processes, depending upon how long you leave those coupons in there. Now, installation of coupon is very, very critical, right? Where the coupons are to be installed parallel to fluid flow. If you install these coupons perpendicular to the fluid flow, then the coupons will be subjected to the fluid impacts, and it can cause extra corrosion due to erosion, right, and due to other flow regime disturbances in there. This technique monitors weight loss. It can also use stress-assisted corrosion by installing stress probes or stress coupons, right? It can also measure the bimetallic corrosion. It can also indicate the differential ration in there if there is a right entry of the oxygen in there. We can change the corrosion rate. It can also be used as the heat affected zones. You can have the probes which are suffering, which are welded and they are subjected to the heat affected can be installed in there. Sensitivity of this technique is about 0.1 millimeter per year. See how you can calculate the corrosion rates from the coupon weight loss. Right? Corrosion rate in mils per year, density, this is a factor given in there. And this formula you can use, which are very common given everywhere, right? How to calculate the corrosion weight loss from the coupons. Corrosion coupons benefits and limitations. There are so many benefits of this technique, and the time is running out. So I have to just speed up some of the slides. And I think you can also read benefits of that technique and the limitation of this technique. Then you can see that corrosion coupons holders, coupons holders, this is a low pressure coupons holders. And these are the high pressure coupon holders and the high pressure coupons. These are the actual devices which are installed right on the pipelines or the vessels. And they can be retracted under pressure, under actually the operating conditions. Same is true with this ones. And these are the actual clamps which are fitted to these devices, right, as a safety measure. Because these devices have a seal in there. If the seal leaks, these probes can always flush out. So in order to protect these probes and from this right unacceptable escape, we always install these clamps, low pressure clamps, hold the probes in the place. Excuse me, please. Then the corrosion monitoring electrical resistance probe. This is a second technique which we can use in the industry, that it's again a physical technique, direct intrusive technique, and it measures the change in resistance in there. It does not measure the loss of weight. It measures the change in resistance in there, and that change in resistance is calibrated into the corrosion rate in mils per year. And this actually the details are given in here. And I have to move fast to the next slide. Corrosion monitoring by electrical resistance, ER benefits, limitations. These are mentioned in there, which you can always read it from the record recorded to this video. The low pressure corrosion monitoring can be installed in 1-inch full port, and the high pressure has to go to the 2-inch access fittings. These are the actual high pressure corrosion monitor ER probes. They have different shapes. Depending upon the rate of corrosion of the system, so accordingly you can select right high pressure ER probes which can meet your requirements and the anticipated corrosion rate. They come in actually pressure rating of more than 1,500 psi to 6,000 psi. This is actually the ER probe installation orientation. Same is true with like the coupons. These probes are installed, they have to orient in such a way that they're not going to be subjected direct to the flow regime or the flow impacts. So we prefer to protect to the probe shields in there which have the holes, right? So the liquid can enter from one side and leave from the other side and from the bottom. So we can reduce or minimize the impact of the fluids on the condition of the probes there. This is the inductive resistance principle and monitoring. I reckon that it is almost 40 minutes gone, right? So this is the other technique which can be used in there. I would just like to go to the LPR. The corrosion monitoring by linear polarization resistance, right? Principle of monitoring all this principle is there. In this, we just polarize the actual probes in there from, right, its corrosion potential to plus minus 10 millivolts. And then we relate that, right, the corrosion density or I core, right, to determine the actual corrosion rate in mils per year using a Faraday's law. These are the actual benefits and limitations, and this is the actual shape of the probes, right? This is a 2 electrode probe, this is a 3 electrode probes. I think the time is almost over, so I will stop it here. I still have many more slides I can talk about, but let us stop it over here.